Okay, so we are going to take a look at these 5 example problems that we have in our example 1 quotient of powers group. So I'm going to use gray to show what I'm thinking, but then I'm just going to write what you would need to write. So the thinking part isn't something that you necessarily have to show every time you do the problem, but I want to help you to understand what I'm thinking. So we have 4 to the 12th power over 4 to the 2nd power. So we're thinking that we're taking this power and dividing by that power. We have the same base of 4, so 4 stays. And then whenever you are dividing powers like this, all you're thinking to yourself is that you have to take the exponent and subtract. So 12 minus 2. So this is the thought process. Now, if you can do this in your head and just say to yourself, okay, keep the base, and then look at this and say 12 minus 2 is 10, that's all you need. So the blue is what you need. This is what I'm thinking in order to come up with that. All right, let's take a look at the next one. Same idea. So in this one, I've got 7 to the 8th power divided by 7 to the 2nd power. There are 8 factors of 7, 2 factors of 7. So if you were thinking about how this would work, you could cross them out. And so we want to think, keep the base, and then we are dividing. So we're taking the exponent and subtracting the other exponent. So 8 minus 2. So that's the thought process. What you really need to write is just 7, and then 8 minus 2 gives us 6. So 7 to the 6th power. Now for these two that we just did, you could actually plug this into your calculator. You could, let me do that real quick so that we can actually get a number with this. So 4 to the caret 10 would be a large number. I'm not going to write that, but that is what it is equivalent to. And then 7 to the 6th power. That's a little bit easier to write, but not really. So I'm just going to leave these numbers in this form because they're a little bit easier to process. Now, in these next examples, we don't have any numbers. We just have variables, but we want to do similar things. So in this next one, I'm going to focus on just the a to the 5th and the a. So these are both powers that have a base of a. And with this, I'm going to do it in gray because I'm thinking, I know that I want to keep my base the same and then subtract my exponents because we're dividing powers. So we've got 5, and I want to subtract whatever the exponent is on this. Now the exponent isn't written, but we need to remember that if there's nothing written, it's a phantom 1. So we're thinking a to the 5 minus 1. So this is all coming from those a's. Now the second part of this, I'm thinking about the b's. So I've got b to the 8th power divided by b to the 3rd power. So I want to keep my base of b, and then I need to subtract the exponent. So 8 minus 3 gives us, well, what does it give us? We're just doing the thinking part, so I'm not quite there yet. So 8 minus 3 is what we're thinking. Now, what you would need to write would only be what I'm writing in blue here. So if you can look at this and say, okay, I know I keep my base of a, and then you can just do 5 minus 1 gives you 4. And then for b to the 8th and b to the 3rd, we keep our b, and then 8 minus 3 is going to give us 5. So again, this is showing what I'm thinking. You do not need to write this part. All you need is the answer here. Okay, in the next one, same idea. We're going to focus first on just our x's. So we've got x to the 8th over x squared. So thinking we want to keep our x and then subtract our exponents. So 8 minus 2. So this is coming from just the x portion. Now next we'll look at the y to the 12th power and the y to the 7th power. We want to keep our y, and then because we're dividing powers here, we want to do we want to find the difference of the exponents. So 12 minus 7 is what we're thinking. So that goes with the blues. Now from here, like if you have been feeling good about this, you don't necessarily need to show the work here, but we're thinking keep the base of x. 8 minus 2 gives us 6. And then y to the 12th, y to the 7th. We keep our y, and 12 minus 7, 7, 8, 9, 10, 11, 12 is 5. Holy cow, have to count that out a little bit. But we are just, you can just simply keep your base and then subtract your exponent. And this is all you need to show. Okay. Last example that we have here, this one is a combination where we have both numbers and variables. So the first thing that I'm going to do is I'm going to focus in on the numbers. So I have -5 divided by 10. Now some of you might be able to recognize that this can be simplified to -1/2. If you are not one of those people, it's okay because the calculator can do the work for us. So I simply type in -5 divided by 10. It gives me a decimal, but we want to try to keep, like they've given us a fraction to begin with, so we want to try to keep that fraction form. So I'm going to hit math, enter, enter, and it does come out to be negative equals -1/2. Okay, so now I have noticed a typo. Now on yours it won't be a typo. Yours should look like this already, but on mine it's wrong. This should be the 6, and there should be no exponent here. So what I'm going to do is I'm going to look at p to the 6th and p, and I want to think to myself, okay, my bases are the same. I've got p, and then, okay, 6, we'll do 6, and then minus the exponent from the bottom, which is not there anymore, so we assume it's a 1. And then the last piece, so let me color coordinate a little bit better with this. The last piece of this is taking a look at the q's. So I've got q to the 7th and q to the 3rd. So I have to think to myself, keep the base of q and then subtract the exponents. So I've got, what I'm thinking here is that I have -1/2 times p to the 5th, because I did 6 minus 1, 6 minus 1, and then q, keep the base, 7 minus 3 would be 4. So q to the 4th. So you could write it like this. Another correct way of writing this would be like if you just had negative p to the 5th, q to the 4th over 2. That would be acceptable as well. But either would be fine. So as you go through these problems, you want to follow similar steps. So like with when the bases are the same and you're dividing them, shown by that fraction bar, all you're going to do is keep the base. So keep 3, and then you're thinking to yourself 13 minus 7, and that's going to be your new exponent. So try your best with these, do what you can. If you need help, you may always log back into the Zoom meeting and ask your questions there. All right, good luck, guys.